This is SpaceTime, Series 22, Episode 86. Coming up on SpaceTime. Unexplained seasonal changes discovered in Martian oxygen levels. Water detected on our latest interstellar visitor. And have astronomers found a new class of black hole? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have detected seasonal changes in oxygen levels in the air directly above the surface of Gale Crater on Mars. The unexpected readings have come as researchers continue to try and solve the mystery of the red planet's seasonal changes in methane levels. Over the course of 3 Martian years, that's nearly 6 Earth years, an instrument aboard NASA's Mars Curiosity rover has been monitoring and analysing the composition of air in Gale Crater. The results show the makeup of the Martian atmosphere at the surface is about 95% by volume carbon dioxide, 2.6% molecular nitrogen, 1.9% argon, 0.16% molecular oxygen, and 0.06% carbon monoxide. The data also reveals how the molecules in the Martian air mix and circulate with changes in air pressure throughout the Martian year. These changes are caused when carbon dioxide gas freezes over the Martian poles in the winter, thereby lowering the air pressure across the entire planet following the redistribution of air to maintain pressure equilibrium. Then, when the carbon dioxide evaporates again in the spring and summer, it mixes across the red planet, again raising the overall air pressure. Within this environment, scientists found that nitrogen and argon follow a predictable seasonal pattern, waxing and waning in concentration in Gale Crater throughout the year relative to how much carbon dioxide's in the air. And they expected oxygen to do the same thing. Trouble is, it didn't. Instead, the amount of oxygen gas in the air rose throughout spring and summer by as much as 30%, and then dropped back to levels predicted by known chemistry in the fall. A report in the Journal of Geophysical Research found this pattern repeated each spring. However, the amount of oxygen added to the atmosphere varied, implying that something was producing it and then taking it away. It's the first time scientists have seen anything like this, and they're still trying to work out exactly what's going on. Right now, they have no explanation. One possibility is that carbon dioxide or water molecules could have released oxygen into the atmosphere by breaking apart, leading to a short-term rise. The problem is that would take 5 times more water than Mars has to produce the extra oxygen, and carbon dioxide would break up too slowly to generate that amount of oxygen over such a short period of time. And all that wouldn't explain the oxygen seasonal decrease. Another option involves solar radiation breaking up oxygen molecules into 2 separate atoms, which could then blow away and degas into space. But that's also unlikely, as it would take 10 years for the oxygen to disappear through this process. The study's lead author, Melissa Traynor from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says her team is struggling to try and explain it. The fact that the oxygen behavior isn't perfectly repeatable each season suggests that it's not an issue to do with atmospheric dynamics. That means it's probably some chemical source and sink that they simply can't account for. To scientists who study Mars, this oxygen mystery is curiously similar to that of the methane mystery. Methane is constantly in the air inside Gale Crater, but it's in really tiny quantities, in fact just 0.0000004% on average. And that's barely discernible, even using the most sensitive instruments on Curiosity. Still, the 6-wheel rover has found that while methane does rise and fall seasonally, it increases in abundance by about 60% in summer months for inexplicable reasons. In fact, methane can spike randomly and quite dramatically, another mystery scientists are still trying to solve. With the new oxygen findings in hand, Traynor and colleagues have begun wondering whether chemistry similar to what's driving methane's natural seasonal variations is also driving the changes in oxygen. Oxygen and methane can be produced both biologically through microbial metabolism and geologically through chemical reactions related to water and minerals. And scientists are considering all options, although they really don't have any convincing evidence for biological activity on Mars. They expect that non-biological explanations are far more likely, and are working to try and better understand what's likely to be happening. The authors have considered Martian soil as a source for extra springtime oxygen. After all, it's known to be rich in the element in the form of compounds such as hydrogen peroxide and perchlorates. In fact, one experiment decades ago on the Viking landers showed that heat and humidity could release oxygen from the Martian soil. But the thing is, that experiment took place in conditions which are quite different from the Martian spring environment, and it still doesn't account for the oxygen drop. Other possible explanations also don't quite add up for now. For example, high-energy radiation of the soil could produce extra molecular oxygen in the air, but it would take 1 million years to accumulate enough oxygen in the soil to account for the boost measured in just one spring. And so, the mystery continues, at least for now. You're listening to SpaceTime. Still to come, another 350 previously unknown near-Earth objects have been detected over the past month, and later in the science report, discovery of a new health risk from spaceflight that could have deadly consequences. All that and more still to come on SpaceTime. Astronomers have detected signs of water spewing from the interstellar comet 2I Borisov, which is about to make its closest approach to the Sun before beginning its trek back out of the solar system. The discovery, reported on the physics website archive.org, isn't surprising, as comets contain lots of water. But this is the first time astronomers have seen interstellar water in our solar system. In fact, the discovery demonstrates how water can travel between stars. Borisov was first detected back on August the 30th. It's only the second interstellar object discovered in our solar system, after 2017's Oumuamua. Astronomers studying Borisov using the 3.5-metre telescope at the Apache Point Observatory in New Mexico detected the oxygen signatures in the comet's spectra. And the authors say the most likely explanation for this oxygen signature is water breaking apart into hydrogen and oxygen. The researchers then compared the amount of water in the comet to the amount of cyanide it contains, which had been previously measured by another team. And they found the ratio of water to cyanide similar to that of comets belonging to our solar system. When I checked a short time ago, Borisov was some 329 million kilometres from Earth, in the southern hemisphere constellation of Sextans. It'll make its closest approach to the Sun and its perihelion on December the 8th. And as it moves closer to the Sun, it'll warm up, triggering increased levels of degassing, thereby spraying out more gas and dust. And that'll give scientists a chance to see more signs of water and other molecules spewing off the comet over the next few weeks. Exciting times ahead. You're listening to SpaceTime. Still to come, a new class of black hole, well, maybe. And later in the science report, a new study warns that Antarctica is likely to drive rapid sea level rise under climate change. All that and more still to come on SpaceTime. The European Space Agency's NearEarth Objects Co-ordination Centre has detected another 350 previously unknown NEOs, or near-Earth objects, over the past month. That brings to 1,969 NEOs discovered so far this year. And it means there are now some 21,254 asteroids and 108 comets which can be classified as near-Earth objects. A near-Earth object is a celestial body whose orbit brings it to within 1.3 astronomical units of the Sun, and therefore close to Earth's orbit around the Sun. An astronomical unit is the average distance between the Earth and the Sun, which is approximately 150 million kilometres or 8.3 light minutes. Over the past month, the closest encounter with Earth from a NEO occurred on the last day of October, when a 2-metre-wide asteroid, catalogued as 2013 UN13, zipped past the Earth at an altitude of just 6,200 kilometres above the planet's surface. That's closer than many satellites. And it was one of 11 asteroids that passed the Earth closer than the distance to the Moon. A not-so-comforting thought. You're listening to SpaceTime. Still to come, 60 more Starlink satellites launched by SpaceX, and China accelerates what seems to be an extremely busy satellite launch schedule. All that and more still to come on SpaceTime. A team of scientists are proposing a new class of black holes, smaller than the usual stellar mass black holes, but larger than hypothetical primordial black holes. The authors say this new class of black hole, around 2.5 times the mass of the Sun, might explain some of the unanswered questions which are plaguing physicists about the cosmos. See, black holes are really important in terms of how physicists make sense of the universe around them. So important, in fact, that astronomers have been trying to build a census of all the black holes in the Milky Way galaxy. Now, a report in the journal Science, suggesting a new way to search for black holes, has shown that it is possible there could be a class of black holes that are smaller than the smallest known black holes in the universe. The study's lead author, Todd Thompson from Ohio State University, says he's finding hints of this new black hole population. He says discovering this new population of black holes opens up a whole new area of study, telling scientists more about which stars explode in supernovae, which don't, which form black holes, and which will form neutron stars. Thompson says imagine a census of a city that only counted people 5'9" and taller, and imagine that the census takers didn't even know that people shorter than 5'9" existed. He points out that data from such a census would be incomplete, providing an inaccurate picture of the population. And that's essentially what Thompson thinks is happening in the search for black holes. Black holes form when really big stars die, shrink into themselves and explode. The next step down from a stellar mass black hole is a neutron star, a smaller, dense stellar corpse that forms when a star much larger than the Sun dies and collapses. Both stellar mass black holes and neutron stars could hold interesting information about the elements on Earth and how stars live and die. But in order to uncover that information, astronomers first need to figure out where black holes are. And to figure out where black holes are, they need to know exactly what they're looking for. One clue is that black holes often exist in what are known as binary systems. This simply means the two stars are close enough to each other to be locked gravitationally in a mutual orbit around one another. When one of those stars die, the other remains, still orbiting the space where the dead star, now a black hole or neutron star, once lived, and where the black hole or neutron star has now formed. Now, for years, scientists have known that collapsing stars greater than 1.4 times the mass of our Sun, the so-called Chandrasekhar limit, will collapse down to form a neutron star. But exactly where's the upper limit for a neutron star? A couple of weeks ago, we reported observations that it could be around 2.3 to 2.5 solar masses. And that's what Thompson and colleagues are on about. They want to know exactly where the cutoff is from a star becoming a neutron star when it collapses to one that's going to become a black hole instead. So they've been combing through data from Apogee, the Apache Point Observatory Galactic Evolution Experiment, which has been collecting light spectra from around 100,000 stars across the Milky Way. The spectra is important because it can show whether a star is orbiting around another object. Changes in the spectra, such as a shift towards bluer wavelength, for example, followed by a shift towards redder wavelength, could show that a star is orbiting an unseen companion. And so they look for stars showing this change, indicating there might be a black hole involved. The authors then compared this data with thousands of images of each potential binary system from ASSASSIN, the all-sky automated survey for supernovae. Eventually, they found a giant red star that appeared to be orbiting something, but that something, based on their calculations, was likely much smaller than most known black holes in our galaxy, but at the same time, way bigger than most known neutron stars. After more calculations and additional data, they realized that they had found a low-mass black hole, likely around 3.3 times the mass of the Sun. Now, it's still not the 2.5 solar masses detected by other studies, but it is a new way of searching for black holes, and potentially opens up a new class of low-mass stellar mass black holes astronomers hadn't previously thought much about. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
The black hole, maybe, which could be the lowest mass black hole yet discovered at, 3.3 times the mass of our Sun, which isn't super massive at all, really, when you think about it.
It's not. That's quite correct. This is a very interesting set of observations. What astronomers have found is the smallest yet known black hole, but it might be the biggest yet known neutron star.
Here we go.
Yeah, that's
potato,
right.
potato.
It's always, there's always caveats in these things. Let's just review what we know about black holes. They come in basically two classes. The supermassive black holes, which are things with masses millions or billion times the mass of the Sun, which sit at the centers of galaxies, and they've probably grown that size by gobbling up lots and lots of debris and material that have surrounded them over the maybe 12 or 13 billion years that they've been in existence. But then there's what we call stellar mass black holes. These are black holes with masses which are greater than the mass of the Sun, but sort of typical of some massive stars. And those, we understand, have masses in the range typically of about 5 to 15 times the mass of our Sun. They might be bigger than that. Some of them are probably bigger. In fact, we know some of them are bigger because the gravitational wave experiments that have been done by the LIGO detector and Virgo, its counterpart in Italy, they've shown collisions with objects involving mergers of black holes, which are perhaps 20 30 times the mass of the sun, so relatively big. But the smaller ones, 5 to 15 times the mass of the sun, are revealing themselves actually by their X radiation. And so what you have, and this is a fairly common phenomenon throughout our galaxy. By that, I mean, we know of, I don't know, I suppose a few dozen of these things. I'm not an X-ray astronomer, so I might be exaggerating there, but certainly the very first one, Cygnus X1, works by this mechanism. If you have two stars, one of which, and they get to the ends of their lives, one of which is massive enough that when it blows up as a supernova, its core collapses into a black hole. If you've got that phenomenon and another companion star in orbit around it, if that companion star is close enough, then you'll get material sucked off the companion star, which will go into the accretion disk of the black hole. This is this spinning disk of material around the black hole. And that's where the X-rays come from, because there's so much energy in this spinning disk of material. The particles banging together, they actually create X-rays. And so you get a very strong X-ray source, plus the fact that there are these beams of material being spurted out from the poles of the black hole by the fact that it's highly magnetized. So that's the way that black holes, these stellar mass black holes, 5 to 15 times the mass of the sun, that's the way that they have mostly been discovered. But a group of scientists at the Ohio State University in the US, they've thought slightly outside the box about this and said, what if we're missing something here? What if there are some black holes in orbit with other stars orbiting around them, which are not close enough to have this transfer of material from the companion star down to the black hole's accretion disk? Mm-hmm. So you wouldn't see any X-rays. You would not know that there was an X-ray source there. You wouldn't know that there was a black hole there. That's probably what I'm trying to say, because there's no X-rays being produced. And so what they've done is they've done what the planet hunters do. They've looked at the way stars which are visible in the sky, and they're relatively faint, but big telescopes can detect them. Look at the way that they move with what's called the Doppler effect, the fact that as a star comes towards us or goes away from us, we can pick up its motion by means of the device we call a spectrograph, which breaks the light up into that rainbow of colors with the barcode of elements, signatures imprinted on it. So you use one of those and you look for slight variations in the velocity of the star, which you can measure by means of the spectrograph. And if you do that over a long period of time, you can see the motion of the star, which is caused by something orbiting around it. And that's how we detect planets. It's called the Doppler wobble method. But you can kind of invert that. You can look at the way a star's velocity is changing, and then you can infer from that it may well be in orbit itself around something highly massive, because you can do the geometrical analysis of this sort of thing. And that's what these astronomers have done. They have detected something about 3 times the mass of the sun, that's the large star itself, being tugged backwards and forwards by its companion object once every 83 days. But that companion object has a mass of probably 3.3 to maybe even as much as 6 times the mass of the sun. And the fact that it's invisible, because all you see is the star going around it, suggests that that is a black hole. It's the fact that it's compact as well. So we've got here the first evidence that there is a class of objects that we haven't seen before, black holes, which are in that maybe 3 to 5 solar mass range, where you don't get X-ray emission from the material around the black hole, but you've got other evidence to suggest that it's there. So this is an interesting piece of research that may lead to a whole new field of study in black hole physics. Yeah. There's a term for them. They're being called non-interacting black holes. That's to say black holes that don't interact with their companion stars.
Okay. Because we did talk, you mentioned at the beginning, there were 2 classes of black hole, the supermassive and the smaller variety. These are possibly smaller.
Smaller still.
We always thought there was, why wasn't there anything middle-sized? And we've started to discover, well, there are. Yeah, it seems. And now we're finding even smaller ones. So it's starting to look like they might come in all sizes.
Yeah, in all shapes and sizes. I have to say that the intermediate mass black holes, as they're called, things with a mass of 100 or 1,000 suns, those are still very much in the minority. There are one or two that are candidates for those objects, but there's still a big gap between the black holes that we can detect by X-rays and the black holes we detect in the centers of galaxies. There's a big gap in there of missing intermediate mass black holes. That's a problem that I don't think has yet been solved. But this, in some ways, adds to the mystery because it says, well, you can get even smaller ones as well that aren't interacting with their companion stars.
Yeah, it is fascinating and so much more to learn. We'll crack it one day. It might take a long time. I wondered, though, while you were talking, if there have been discoveries in astronomy in the past where people have sat down and gone, now, wait a minute, we're looking at it from this perspective. What if it's something else? And they've started looking into it and gone, voila. Has that happened much?
Yeah.
Does it happen like that all the time?
I mean, often, perhaps the classic example of that goes back to the 19th century when an astronomer called Leverrier believed that because of a peculiarity in the motion of Mercury around the sun, he believed that there was a planet between the sun and Mercury. And that was commonly accepted for 50 years, that there was a planet. It was called Vulcan. Nobody had ever seen it. People had tried to observe it. A couple of people thought they'd seen it, but it was never there. But it was just assumed by astronomers that it was a real object. And it was only when Einstein put together his general theory of relativity and found that the fact that gravity behaves a little bit differently when you're really close to the sun than Newton predicted, that's then accounts for the observed anomalies in Mercury's orbit. And as soon as you put relativity into the thing, the need for Vulcan just disappears. It was a complete red herring. And who's to know? We might be following other red herrings in astronomy today.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. SpaceX has launched another 60 Starlink microsatellites as part of its plans to establish a global high-speed internet satellite network. They'll join 60 identical satellites launched by the Hawthorne, California-based company last May. The new spacecraft will all sent into orbit aboard a single SpaceX Falcon 9 rocket launched from the Cape Canaveral Air Force Base in Florida.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. With gratitude to our veterans today and always, go USA.
Falcon 9 is pitching downrange.
Stage 1 cross is nominal.
Power and telemetry is nominal.
We've had a on-time liftoff, the Falcon 9 vehicle making its way to orbit. We are coming up in about 10 seconds here on max Q. That is the maximum aerodynamic pressure that the vehicle will see during ascent. We should be able to hear that call out.
Vehicle's experiencing maximum aerodynamic pressure.
And there's that call out for max Q. Coming up next is a rapid succession of events, starting off with main engine cutoff, or what we call MECO, followed immediately by stage separation. That's the separation of the first stage from the second stage. And then seconds after will be the lighting of our second stage engine, which we call second engine startup, or SES-1.
MECO.
Stage separation confirmed.
We had MECO and stage separation, and there's that second stage engine glowing bright red. Coming up next in about 30 seconds is fairing deployment. Now, a reminder, this fairing is being flown for a second time, which is a first in SpaceX history. Grid fins have been deployed, and there is our fairing deployment. This is the first reflight of our fairing, so such an exciting mission this morning already.
As the second stage continues to orbit with those 60 Starlink satellites on top, stage 1 is making its way home for the fourth time. Now, stage 1 is going to execute 2 burns before hopefully it's standing there on our drone ship. The first one will be the entry burn, which occurs at about T plus 6 minutes and 23 seconds, so a little over 2 minutes from now. That's where we're going to relight 3 of those Merlin engines and slow the vehicle down such that it can safely re-enter the atmosphere. From there, the booster do a coast for just under a minute and a half, and then execute what is called the landing burn. That is where we're going to reignite a single engine, that E9 engine right in the middle of the booster, slowing the vehicle down to zero velocity, hopefully standing right there up on the drone ship. Meanwhile, stage 2 continues to fly nominally. We're hearing that MVAC-D power is nominal and continues at full power. Stage 2 pressures, the tank pressures are nominal as well.
First and second stage are on a nominal trajectory.
That MVAC engine is powering that second stage and those satellites with 250,000 pounds of thrust.
Stage 1 FTS is saved.
Stage 1 entry burn.
That entry burn has begun. Should go for another 5 seconds or so.
Stage 1 entry burn shutdown.
As you just heard, we had a successful shutdown of that entry burn. So for about another minute and a half, stage 1 is going to coast, making its way down to the drone ship. And at
First
T+,
and second stage continue to follow a nominal trajectory.
And in just under a minute, that landing burn should start.
Stage 1 transonic.
Everything continues to be nominal on stage 2.
Stage 1 landing burn.
Second stage has entered terminal guidance.
Stage 1 landing leg deploy.
And wow! The Falcon has landed for the 4th time. These boosters are designed to be used 10 times. Let's turn it around for a 5th, guys. Wow, 4th landing. That is super cool. So stage 2, I believe we have had SECO 1. We're going to enter a coast phase.
SpaceX has now received authorization from US authorities to launch at least 12,000 Starlink satellites into several different orbits. And the company's boss, Elon Musk, says the Starlink constellation could eventually consist of some 42,000 satellites, greatly expanding internet access around the globe. The mini satellites are initially orbiting at an altitude of 550 kilometers, but as we mentioned earlier, that will change as more come online. Starlink expects to begin its services across the US and Canada next year. Musk hopes to eventually have up to 5% of the global internet market. That's a slice valued at more than $30 billion annually, 10 times more than SpaceX earns from rocket launches. But SpaceX isn't alone in its lofty ambitions, with rivals including OneWeb and Amazon having very similar plans. But the idea of adding thousands of satellites does have astronomers worried, because the proliferation of so many satellites glinting in the sky will affect their research. Starlink Skytrains, as they're being called, are already being detected with just the satellites already up there. Increasing satellite populations also increases the risk of collisions between satellites and their resultant cascades of space junk, making conditions in orbit even more dangerous. Well, it seems Beijing shifted into high gear with an accelerating launch schedule during the closing months of the year. It's just launched another satellite in its ever-growing BeiDou or Compass satellite navigation system. The latest BeiDou 3 was launched aboard a Long March 3B rocket from the Xichang Satellite Launch Center in southwestern China's Sichuan province. The BDS-3 IGSO-3 is the 49th satellite in the BeiDou constellation, the 24th satellite of the latest BDS-3 system, and the third BeiDou 3 navigation satellite to be positioned in an inclined geosynchronous orbit. The BeiDou launch followed the earlier launch of the new TJSW-4 experimental spy satellite. The technology demonstrator was also placed into orbit using a Long March 3B from Xichang. While Beijing are keeping the exact details of the new spy satellite a secret, it's understood it'll test new multi-band high-speed communications technology, focusing on gathering signals intelligence data and communications from other countries. Just a week before the TJSW-4 launch, China flew its new Gaofen 7 Earth observation satellite, which Beijing says will play an important role in land surveying and mapping. The probe was launched aboard a Long March 4B rocket from the Taiyuan Satellite Launch Center in northern China's Jiangxi province. Gaofen 7 is China's first civil-use optical transmission three-dimensional surveying and mapping satellite operating in the high-resolution sub-millimeter scale. The same flight also launched 3 commercial experimental microsatellites. And Beijing has also just launched a Long March 6 rocket from Taiyuan carrying 5 Earth observation satellites into space. And just hours prior to that launch, Chinese commercial launch company X-Pace used its Kaoju 1A solid fuel rocket to carry the Jinlin 1 Gaofen 02A remote sensing satellite into orbit from the Zhuquan Satellite Launch Center in the Gobi Desert. Certainly a busy couple of weeks for Beijing's space industry. And time now to take another brief look at some of the other stories making news in science this week with a Science Report. A new study by scientists with the Australian National University warns that Antarctica is likely to drive rapid sea level rise under climate change. Researchers examined historical and new data from the last interglacial, which took place between 125,000 and 118,000 years ago. They were shocked to see sea level rise up to 10 metres above current levels. Interglacial is a period of warmer global temperatures that can last thousands of years. The study, reported in the journal Nature Communications, found that sea levels rose by up to 3 metres per century, largely driven by ice loss in the Antarctic ice sheet. Of course, the last interglacial sea rise was due to natural climate instabilities, and was therefore both smaller and much slower than the greenhouse gas-driven human-caused climate change now underway. The study shows for the first time that early Antarctic ice loss was caused by Southern Ocean warming at the very onset of the interglacial. Next, the meltwater from Antarctica caused changes in global ocean circulation that resulted in northern polar warming and associated Greenland ice loss. The authors warn that today's climate change is far greater and developing much faster than that of the last interglacial, and as a result the rates of sea level rise may develop over the next several centuries that are even higher than those found for the interglacial. Has your Apple Watch ever told you that your heartbeat's irregular? If it does, it may be worth getting it checked out, not your watch, your heartbeat. You see, a new study suggests that around a third of people who receive this alert are actually suffering from atrial fibrillation. It's a type of irregular heartbeat that puts you at a 5 times greater risk of stroke. The study, reported in the New England Journal of Medicine, looked at more than 400,000 Apple Watch users. It found less than 0.5% received notification of an irregular pulse. But among those that did, 34% had atrial fibrillation, confirmed by an EEG patch test. Pollution caused by people's use of antidepressants which are eventually excreted into the waterways has been found to disrupt the behaviour of fish. A report in the journal Biological Letters claims that when researchers recreated environmentally realistic conditions of a common antidepressant in a specific water habitat, solitary fish showed little impact, but in social groups the drug disrupted foraging behaviour, with reductions in levels of aggression and overall food consumption. Scientists say the social context may be an important but underappreciated factor influencing the ecological impacts of chemical pollutants on wildlife. A new study warns that phosphate mining is affecting the health of coral reefs, reducing natural diversity and slowing down growth. The findings are based on research by the Australian National University, which examined coral reefs around Christmas Island in the Indian Ocean, which has undergone extensive phosphate mining for hundreds of years. A report in the journal Science of the Total Environment found reefs near the island's mining hotspots suffered high levels of pollution. Runoff and sediment pollution was found to be smothering reef organisms, preventing light from penetrating down the water column, killing once healthy reefs, and decimating fish populations. Scientists have discovered a new health risk from spaceflight that could have deadly consequences. A report in the Journal of the American Medical Association, which examined 11 crew members from the International Space Station, found that 6 of them had developed a stagnant or backwards flow in the internal jugular vein, a major blood vessel coming from the head. They also found that one of the crew members had developed a blockage or thrombosis of this vein during spaceflight. The authors say that although humans have been flying in space for more than 50 years, this is the first report of venous thrombosis during spaceflight to their knowledge. They say the findings may have significant human health implications for civilian spaceflight, as well as future exploration class missions, such as those to Mars. Britain's National Health Service has released a series of investigations warning of the dangers of anti-vaccination claims by homeopaths. It seems thousands of children have been put on homeopathic alternatives to vaccination by practitioners who claim they can prevent measles and cure autism. The controversial treatments are known as homeoprophylaxis and cease, but they have no scientific or medical support, and their claims of cures or protection are simply false. Tim Mendham from Australian Skeptics says homeopathy's movement into vaccination alternatives poses a real health concern, with measles already killing thousands of people.
This has been an ongoing campaign in the UK by the Good Thinking Society, which is actually a group that's subsidised or supported by Simon Singh, who's quite well known in the alternative medicine area as a critic. They've been running a campaign for a while to get the National Health Service in the UK to stop funding homeopathy, and they have succeeded by and large in doing that, because homeopathy basically has no scientific standing at all. Now the head of the National Health Service itself has written to virtually every newspaper in the UK, pointing out that very fact that homeopathy has no basis in science, and also, especially because the homeopaths, a lot of them are now very anti-vaccination and are proposing their own homeopathic treatments instead of traditional vaccinations. So they're not just sort of benign anymore, they are quite a serious danger to the population. So that's what the head of the NHS said. That received a lot of publicity, and several sort of major papers carried his statement, including The Guardian, The Times, BBC, The Telegraph. Quite a few different places were picking up on this. So it looks like a concerted effort in the UK to basically at least limit homeopathy, from what I can say, if not sort of really sort of take it down, as opposed to other places. In Germany, there's a big battle going on about homeopathy there right now.
Well, Germany was the birthplace of homeopathy, wasn't it?
That's right, yeah. And about however long ago it was, 200 years ago, whatever it was.
Something like that.
And yes, so therefore, there's been a big battle there. Same in France. Homeopathy's had a big following in France. But gradually, countries one by one are sort of seriously looking at what homeopathy is about. And following what happened in Australia with the National Health and Medical Research Council, who put out a paper pointing out that there is absolutely no science behind homeopathy, which really upset the homeopaths across the world. Probably even more so than the homeopaths here, actually. But we see a lot of publicity. And there is no truth to homeopathy at all. I mean, sort of even people who claim, well, yeah, there might be a placebo effect. Really, it's not a good excuse to actually giving something that's useless. Expensive water, as they say.
That's Tim Mendham from Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary. And you can also find us on the Spacetime with Stuart Gary YouTube channel. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.